Hello everyone, we are from Group 4 and we are here to cover the presentation of the classification of underground cable. So let me introduce myself. My name is Linda Lo and the matrix number is AM190179. Yeah, so we have 6 of the members in this group. Next is the table of content. So in this subtopic we have the 5 of the point. So the first is the number of the conductors in the cable, second is the voltage rating of the cable, the third is the construction of cable, the fourth is the type and thickness of insulation used, and the last is the installation and laying of the cable. Okay, the first point is the number of conductors in the cable. So a cable may have one or more than one core depending upon the type of the service for each is intended. It may be the single core, the 2 core, 3 core, 4 core, and so on. Okay, so for the 3-phase service, either the 3-phase core cable or the 3-core cable can be used depending upon the operating voltage and the load demand. So as we can see, the figure 11.2 show the constructional details of the single core low tension cable. So the cable has ordinary constructions, and because the stresses developed in the cable for low voltage with up to the 6600 volts are generally small and is of one circular core of thin stranded copper or aluminium insulated by the layer of the impregnated paper. So the insulation is surrounded by a lift sheath. So we can see here is the lift sheath, and which prevent the entry of moisture into the inner part. So in order to protect the lift sheath from corrosive, and the overall surveying of the compound fibrous material is provided. For the single core cable are not usually merged in order to avoid the excessive sheath losses. So in the principle of advantage of the single core cable are the simple construction and availability of the larger copper section. So let us go to the single phase power cables. The first is the 2 core and the earth cable. So in this figure we can see the new color and the old color of the 2 core and earth cable. So the cable has a 3 core and live, neutral, and the earth. So for the live and neutral core are insulated and carry the current to and from the outlet socket. So this cable is connect the consumer unit to the power outlet socket and carry the electricity to appliances which are plugged into the socket. So the second one is the 3-core flex. The flex cable has 3 core being live, earth, and neutral. So each of the core is insulated with a layer of color called PVC. All 3 cores are then surrounded by an additional outer PVC layer as known as the sheath. So in this type of the cable are usually connect such as the lamp or the extension cable to the power outlet socket. The third is the 2-core flex. So this type of the cable is connect small appliances which are double insulated and need no earth. So as this is the flex cable, it will be of circular shape and with an outer sheath and two color coded PVC insulator cords. So next, go to the 3-phase power cable. The 3-phase and neutral. So the first one is 3-phase and neutral. So the 3-phase cable are usually circular and contain 4 core and 3 of them being live and 1 being the neutral. Okay, so each of the core is covered in a color called PVC insulation and then grouped together and covered in a layer known as the sheath. So this is the inner sheath. This is then surrounded by a layer of twisted galvanized steel wire which has a dual purpose of providing a merge protection as well as the circuit protection conductor which is the CPC and then the emerge layer is then covered in an additional layer of PVC insulation which protect the emerge from rust. Yeah, so this is also the new and the old color coding for the three-phase and neutral cable. So the color of the three-phase core was changed to align in with the requirements of the Europe. So for the left hand side is the old color and the right hand side is the new color. So it is important to remember that the color change because the new and the old style of the color coding will mix together in a commercial or in the industrial building. Yeah, although there should be a warning or sticker as well as the face labeling. This type of cable is used for wiring two-way light switches. The cable consists of four cores, with one being the neutral and the other three potentials being live depending on the way the lighting circuit is designed and what position the switches are in. So here we can see the maybe live, earth, maybe live, and the maybe live. So this is a three core and the earth cable, new color and the old color figures. So the last is the type of the cable used for wiring light fittings with plastic lamp holder which do not require an earth. The cable only has the two core being live and neutral. So this is such as the single phase. Yeah, so the single phase also have the two core flags. So in this is the same cable with the single phase in these lighting cables. So my presentation is until here. Thank you very much.
Hi, my name is Nur Muhammad Ashraf bin Nasruddin. So I will present about the voltage rating for underground cable. So in voltage rating, we have five classification which are low tension cable, high tension cable, super tension cable, extra high tension cable, and extra super tension cable. For rating, low tension cable is below 1 kilovolt, and high tension cable is below 11 kilovolt. Super tension cable is below 33 kilovolt. Extra high tension cable is below 66 kilovolt. And extra super tension cable is higher than 132 kilovolt.
Hi, my name is Coming Ray, and I will be presenting about the subtitle 3, Construction of Cable. So, a typical underground cable will consist of conductors covered by a number of insulating and protective layers necessary for its satisfactory operation. The example of the underground cable construction is shown as below. As we can see on the picture, there are a few layers on the serving, bedding, insulation screen, conductor screen, stranded conductor, insulation, metallic shaft, and armoring. For the conductor, is usually 2 or 3 conductors are used. These conductors are stranded in order to reduce the skin effect and proximity effect. On the conductor screen, it is a semi-conducting tape or an extruded layer of semiconduction compound. For insulation, is merely for providing to withstand the stress, electrostatic stress. And for insulation screen is a layer of semiconductive material generally used in MV and HV lines. On the armoring is basically to provide mechanical protection from stress that may get exposed during installation and operational life. Basically just increase the lifespan of the cable. And for the serving, another layer of low grade insulator to protect the cable from steel and atmospheric contamination. That's it. Thank you.
My name is Muhammad Zulkarnain bin Murtaza. I will cover about type and thickness of insulation used. but on I will my part is my type of insulation used. Okay, the certificatory operation of a cable depend to a great extent upon the characteristic of insulation used. Okay, so as you want to know, the underground cable is under the ground. So to it's very expensive to maintain. So to we must make sure that cable that we use are very good, and insulated material is one of the considered to make sure the protection of the cable core is important. Okay, so this type is should have to make sure the insulating material for underground cable. First is high insulation resistant to avoid leakage current. So as you know, this cable is underground. So to make sure there's no leakage current to avoid many type of maintenance. So then the cost of the maintenance will be reduced. So high dielectric strength to avoid electric breakdown of the cable. So uh, the cable underground is to transfer the high voltage. So high dielectric strength is to void electrical to make sure the electrical to deliver from from receiver to consumer is not breakdown of the cable. So high mechanical strength to withstand the mechanical handling of cable. High mechanical is more to the compact of the cable. The strength mechanical is outside the cable. We need to know is nothing happen easily damage. Non-hygroscopic, for example, not absorb moisture from air or cell. So because the electrical is exposed to the water or soil is decrease the insulation resistance and hence the breakdown cable. In case the insulator is the high percent, it must enclose the waterproof uh, to make sure the cable is safe. So the next is non-inflammable is very important. And lastly, second last is low cost to make the underground system viable. So that's why I said one is make sure the all cost of the to make the material of the underground cable is important to make sure the cost of maintenance is lost. And lastly, unaffected by acid and alkali to avoid any chemical action. So this type of insulation material have many type. For we want for I show on the table is just a type of material that used for this for the Malaysia area. For PVC type A, operating temperature only 75 degrees Celsius. PVC type B 85, PVC type C 85, XLPE is 90 degree, rubber 90 degree. This one, the last one is rubber that we combine with the another element such as silicon or IPR IE2, 4, 3, and 5. So it can operate a maximum 150. So insulation material type is what we can say is use depend on the situation, depend the long range what type of how many voltage that can deliver and how many voltage that can observe by cable that we use for this PVC this use of cable to receive the voltage high voltage. So I think that's all for my part. Thank you.
Hi, my name is Mohammed and I will be continuing on the presentation for the thickness of insulation. So the cable insulation is designed to withstand the voltage stresses a cable will experience over its expected lifetime. An insulation level defines various insulation thicknesses within a single voltage rating. The two most common levels are 100% and 133%. Normally, 100% insulation level is used on a grounded system and is sometimes also referred to as a grounded insulation thickness. Likewise, the 133% level is normally used on an ungrounded system and is referred to as ungrounded insulation thickness. But 172% is uncommon but also exists, and it is normally used on an ungrounded system where further fault clearing time is needed. So the rated insulation level is the value of the impulse withstand voltage and the value of power with frequency withstand voltage, which together characterize the insulation of the switchgear with regards to its ability to withstand the V electric stresses. Insulation levels are designed to withstand surge voltages rather than only normal operating voltages. Since the insulation lines and equipment is protected by surge arresters draining the surges rapidly before the insulation is damaged, the arrestor must operate below the minimum insulation level that must withstand the surges. So, for medium voltage cables, insulation levels greater than 100% are intended to provide an additional safety factor for the unfaulted phase conductors in the event of a fault on one phase in the three-phase system. So, power cable voltage ratings are based on ungrounded Y system. Here is the insulation thickness is based on the cable voltage rating divided by 1.732. So, for example, for a 8 kilovolt rated cable, the thickness is designed for 4.6 kilovolt. This is known as the 100 insulation level, formerly referred to as a grounded system. If a fault exists for less than 1 minute, then the 100% insulation level is suitable. So what about 133%? So the 133% insulation level was designed to use on a system where voltage from the neutral point varies from uh, depending on load balance. This is also referred to as ungrounded system. The basis for the term ungrounded is that each cable is capacitively coupled to the ground via a high reactance path. uh, it does not mean that no grounds are connected to the cable sheet. If the fault exists for than 1 minute but less than 1 hour, then the 133% insulation level is required by the industry standards. So, what about 170%? 173% insulation level is used when a phase to ground fault, depending on the system. It appears as a full phase-to-phase voltage across the insulation for more than 1 hour. So the specified insulation thickness for each insulation level is similar among various industry standards. The thickness varies with insulation level, generally become thicker as the insulation level increases. Typical insulation thicknesses for many medium voltage cables are shown in table. So this is the table for voltage rating and its corresponding insulation level, corresponding voltage for each of the insulation level, which is 100 and 133 and 173%. And lastly, the typical insulation thickness in millimeter. So typical insulation thickness for medium voltage cables that I have shown can be obtained from Insulated Cable Engineers Association standards. So the specified insulation thickness for each insulation levels is similar across various industry standards. The thickness varies with insulation level, generally become thicker as the insulation level increases. Typical insulation thicknesses for many medium voltage cables are shown in the table. So that's all from me.
Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Muhammad Faris Ahmad bin Muhammad Nizam. Today I will present my part, which is installation and laying of the underground cable. Okay, there are three methods of installation and laying the underground cable. First is direct laying, second is draw-in system, and third is solid system. For direct laying, in this method, a layer of 10 cm thickness of sand is sprayed into the trench with 1.5 meter deep and 0.5 meter wide, and then the cable is laid over the sand and it is covered with another layer of sand, and then a wall of brick is provided on the top of cable. For the drawing system, in this method, the cast iron or concrete pipe are laid underground with manhole at suitable position along the cable route, and then the cable are pulled into the pipe from the manhole. For the solid system, in this method, the cable is laid into the alphas trough, and then the trough is filled with bituminous material and covered over by the alphas cover.